Condition tan square theta is equal to 1 plus 2 tan square theta. Prove that this. Now, this is not true always. This is a specific case where some two angle theta, tan of theta and phi are connected in such a way that tan square theta is equal to 1 plus 2. And he says, prove that sine square of that angle theta is equal to 1. So, if this is true, then this is true. Now, how do we think? I mean, how do we try to prove? You see, there are some identity which are always true. That is tan square theta 1 sec square theta is equal to 1 plus tan square theta. Now, what does this mean? That means I can write both this in terms of sec square phi and and why am I doing this? Because actually sec is in terms of cos, and then cos can be converted into sine. So I write this. So this will become tan square is sec square theta minus 1 is equal to 1 plus 2 times sec square phi minus 1. And that makes it sec square theta is equal to 2 plus 2 sec square phi minus 2. And this cancel. So we get cos square 1 by cos square theta is equal to 2 by cos square phi, or cos square phi is 2 cos theta, 2 cos square theta. Now I know I have to convert to this to sine. So I write this as 1 minus sine square theta. And this as 1 minus cos square, 1 minus sine square phi. So now this is 1 minus sine square phi is equal to 2 minus 2 sine square theta. So I take this to this side and this to this side, and it cancels. It get 2 sine square theta is equal to 1 plus sine square phi. So I proved it. So I just now proved it. And that's how you do it. So the concept was try to get tan to sec, tan square theta to sec square theta, and then try to get it in terms of cos square theta, and then try to get it in terms of sine square theta, and similarly with phi, and you get the answer. So you have to plan intelligently. This condition is a particular condition between two angles, but these two are identities. They are always true. That sec square phi is equal to 1 plus tan. So I used both of them. I used this, which is always true, and this conditional to get this condition proved. This is how you plan.